Hello guys, welcome to OLMJ. Today we'll be covering the NSEP PYQs of kinematics. We are starting a new series in which we will be covering the NSEP PYQs chapter wise from 2003 to 2024. So don't forget to like and subscribe. So the first question of kinematics is a particle moves rectilinearly. Its displacement x at time t is given by x square is equal to at square plus b. Its acceleration at time t is proportional to. So we are given the equation of motion of the particle in terms of x and t, and we need to find the acceleration. So we can start by differentiating this equation. We will get 2x dx by dt. Don't forget the dx by dt because we are differentiating in terms of time and not differentiating in terms of x. So let's cancel 2 from both sides. Now we can proceed in two ways. Either we can differentiate this equation once more as it is. So this will become 2 dx by dt. So we are using chain rule and there is one more dx by dt. This dx by dt came because we were differentiating x and we are differentiating with respect to t. So we need to include dx by dt. Second term will become x square x by dt square equal to a. Now we need to use the value of dx by dt from this equation in this equation. So this will become a square t square by x square plus x multiplied by acceleration equal to a. From here we get acceleration is equal to a minus a square t. Now on taking LCM this will become x square minus a square t square by x cube. So till now we cannot comment on the proportionality of acceleration because we have one more variable t other than x. We need to remove t to comment on proportionality. So that can be only done by using the original equation. So if we take a common, this will become square at square cube and x square by x square minus at square is equal to b. It will become ab by x cube. So acceleration is proportional to 1 by x cube. The second method is that we can directly get acceleration by taking x on the other side. It will become at by x and d square x by dt square. Okay, so now while differentiating this we need to be very careful because there are two variables, and so this will become a by x when we differentiate t. And when we are differentiating 1 by x, we need to be careful because it will be minus at by x square dx by dt. Don't forget this dx by dt, it's important. And now substituting the value of dx by dt, we will have a by x minus of a square t square x, and taking the LCM this will become ax a square t. This is same as this equation. This will also give that acceleration is proportional to 1 by x cube. The answer will be option. So now moving on to the second question. The second question says an engine approaches a hill with a constant speed. When it is at a distance of 0.9 kilometers, it blows a whistle whose echo is heard by the driver after 5 seconds. If the speed of the sound in air is 330 meters per second, the speed of engine is. Okay, so we can understand this question by the help of a diagram. Imagine that the engine is at this position at t is equal to 0. And the hill is located at some distance. It is given as 900 meters. And after 5 seconds the engine will be somewhere around here. Since the engine has constant acceleration, we can assume the distance traveled as 5 into velocity of engine. And sound was the sound has traveled this much. We can clearly see that the distance traveled by sound and distance traveled by engine gives the sum of 1800 meters, because sound travels 900 meters first, and then the distance traveled by sound after hitting hill to the engine should be equal to, and the distance traveled by engine should be equal to 900 meters, so that they meet. So we can use this. So distance traveled by sound in 5 seconds will be 330 into 5 equal to 1800. So this will give 5v is equal to 1800 minus 1650. So v will be 30 meters per second. So the correct answer is option A. Now moving on to the third question. The question says a particle starts from point A, moves along a straight line path with an acceleration given by A is equal to P minus Qx, where P and Q are constant, and x is the distance from point A. The particle stops at point B. Find the maximum velocity of particle and distance. So we know that the particle is starting from A. Velocity at A will be 0. And acceleration at A is c, and we put x as 0. Velocity at B is also 0 because the particle stops at. So this is the given information, and acceleration is x. We need to find the maximum velocity. So first we need to find the velocity, general equation of velocity. So we know that acceleration is given as v dv by dx minus q will give by 2 to x minus 2x square. Velocity is given as under root 2p. So we need to find when will the velocity be maximum. So one method is to differentiate this and equate this as 0. But we don't need to do that because we know that the velocity will be maximum when acceleration is 0. Because after that the acceleration will become negative. So velocity will start decreasing till b, where it becomes 0. So somewhere along this path the velocity becomes a maximum when acceleration is 0. So we can find that it is 0 at n x is equal to p by q. Putting p by q here, so will give us that p square by p square q is qp square q square. So this will be p square by q, will be p by q. So we get the maximum velocity as p by q, and find the maximum distance. We know that, no, to find the distance AB, we know that the velocity at B is equal to 0. So when we equate V as 0, so x square is equal to 0, we will get either x is equal to 0, which is at A, because at A also the velocity is 0, and the other solution that we get is 2p by q. So this will be the distance AB. So moving on to question 4. it says that a particle accelerates from rest at a constant rate a for some time, after which it decelerates at a constant rate b and comes to rest. If the total time elapsed is t, the maximum speed acquired by the particle is given by. So the particle originally has constant acceleration a, which is positive, and then it decelerates. So the point where the acceleration changes from a to b, that will be the point of maximum velocity, because before that the acceleration is positive, so velocity will continuously increase. So we can write that v max is equal to 0 at, because the initial velocity is 0 as it is starting from rest. And then we can also write that 0 is equal to v max minus vt, because it comes to rest after it decelerates at rate b. From here we find out that is equal to v max by a. Also, no, t1, the time for achieving maximum velocity, is v max by a, and the time for losing that maximum velocity is v max by b. So the total time elapsed, which is t1 by t2, is given by v max by a b. So this will become t into v max plus a into v max. So we need to find v max only, so this was t, the total time. So v max will be given by ab, a plus t to t. Okay, so moving on to question number 5. It says that a car traveling at 36 kilometers per hour due north turns west in 5 seconds under constant acceleration and maintains same speed. The acceleration of car is. So first we define our working coordinate system, which is north is this, is this, is this, and west is this. I am taking north as j cap, east as I cap. Initially the car is moving with 36 kilometers per hour, which is, we multiply this by 5 by 18, which gives us 10 meters per second in the j cap direction, and then it turns west. This 10 meters per second minus I cap. So we need to find the acceleration. Acceleration is given by v final initial time, which is 10 I cap 10 j cap by 5. So this gives us minus 2 I cap minus 2 j cap. But the options don't contain the answer in this form. They contain in the form of magnitude and then direction. So magnitude can be given by the formula modulus of v1 plus v2 is given by v1 square plus v2 square plus 2v1 dot v2. The modulus of this thing will be 4 plus 4 plus 0, because I dot j is 0. So this will become 2 root 2. And for direction, we can easily see that since this is minus 2 I cap, so minus 2 I cap, minus 2 j cap, so direction will be southwest. So the answer is option A. We can also find the direction in one more with one more method, that is that the direction is given by v vector divided by, we get the unit vector, which is minus 2 I cap minus 2 j cap by 2 root 2 is root 2 by root 2. And if you take the dot product from I cap and j cap, you will find out that direction is southwest by checking the angle. The next question is, a lift whose cage is 3 meters high is moving up with an acceleration of 2 meters per second, where a piece of stone is dropped from top of the cage when its velocity is 8 meters per second. Then the stone will reach the floor of the lift after. So there is a lift whose cage is 3 meters high and it is moving up with an acceleration of 2 meters per second. And a piece of stone is dropped when the cage of the lift has velocity 8 meters per second. So the best method to solve this question is by relative motion, because if we don't use relative motion, then when the person is throwing the piece of stone at this instant, then the stone will also drop down and lift will also move up. So we will need to calculate the distance of two bodies. But if we use relative motion, life will become simple. So the relative acceleration can be given as, we are going in the frame of lift. So the relative acceleration will be given as minus 10 j cap plus 2. This is minus 12 j cap. So now the lift is at rest. So we need to, and also v relative velocity is 8 j cap minus 8. Because the velocity of the stone will also be equal to the velocity of the lift when it is thrown. So it will, the relative velocity will be 0 j cap. Now the stone needs to cover minus 3 j cap distance. So 3 j cap is equal to ut, and u relative is equal to 0 and minus half a into t square. So t will be root of 1 by 2. And in NSEP you have calculator, so you can calculate it as 0.7 seconds. Question 7 says, 4 rods each of length L, this should be L, have been hinged to form a rhombus. Vertex A is fixed to a rigid support, vertex C being pulled to the right along x-axis with uniform speed v as shown. The speed at which vertex B moves at the moment the rhombus takes the shape of the square is. So we know that we can assume this as theta. So we'll get the coordinates of C as, x coordinate of C will be 2L cos theta 0, because this length will be L cos theta if we form a triangle, and this is also theta because this is an isosceles triangle as the length is equal. This will be also L cos theta, so L cos theta plus L cos theta gives us 2L cos theta, and the coordinates of B will be L cos theta comma L sin theta. So we know that since the coordinates for both B and C are related, the velocity will also be related. So if we differentiate the coordinates of C, we will get that dxc by dt is equal to vxc is equal to 2L minus theta d theta by dt, and it is given as V since C has only the x component, so this will be V. And if we differentiate the x coordinate of B, we will get minus L sine theta d theta by dt, and we can clearly see that this velocity is half of x velocity of V of C. Okay, so at this instant, the x velocity of B is V by 2, and this velocity will always remain V by 2 because um, this is moving with constant speed and this has no acceleration, and the relationship between B and C will always be there. So the x component of B's velocity will always be V by 2. So we need to find y component of B velocity of B when the rhombus takes the shape of square. So we know that when the shape becomes square, then the theta will be 45 degree. We can easily see that this will be 90 degree and this will be 45 degree. And we also know that cos and sine are equal at 45 degrees. So at this instant, the y component of B's velocity will also be equal to the x component. So uh, when the shape becomes square, V by B is V by 2 is equal to V x B. So we need to find the magnitude because here the magnitude is given. So it will be V square by 4 plus V square by 4 plus 0 because I dot j is 0. So this will be V by root 2. Option C is correct. So the eighth question is a 12 mark question. So it is a bit difficult, but I'll try my best to explain it. So the question says a motorcycle and a car start from rest from the same place at the same time and travel in the same direction. The motorcycle accelerates at 1 meter per second square up to a speed of 36 km per hour. So this means that after the motorcycle achieves a speed of 36 km per hour, it travels with constant acceleration with 36 km per hour. And same for the car. The car travels at acceleration 0.5 meter per second square up to a speed of 54 km per hour. Calculate the time and distance at which the car would overtake the motorcycle. Okay. So first let's convert this into meter per second. So we multiply it by 5 by 18. So this will be meters per second and this will be 15 meters per second. So first let's calculate when will the motorcycle achieve a speed of 10 meters per second. So for motorcycle, V max is 10 and initially it is at rest. So V is equal to U plus 80. This gives us that time is 10 seconds. After 10 seconds, the motorcycle will travel with constant speed of 10 meters per second. So we can write the equation of the position of motorcycle as follows. The position of motorcycle will be given by two equations, which is first it is traveling with acceleration. So we will use the equation s is equal to ut plus half at square. and since u is 0, this will become half into a into t square, which is t square by 2 till 10 seconds. So there is one more condition, till 10 seconds, and then it will travel with constant speed. So first you need to calculate the distance which it has traveled in 10 seconds, which will be 50. So 50 plus s is equal to ut. So u is 10, and time we are calculating after 10 seconds. So we will use 10 minus t. Let me clarify what I have done. Till 10 seconds plus u t. Hope this makes sense. So this will give 10t minus 50 for t greater than 10 seconds. We can see that both will give the same position at 10 seconds. You can verify that. Let me we do similar thing for motorcycle. No, for car. So for car we know that it travels up to 15 meter per second at acceleration half. So it will be is equal to u plus half t, which gives t is equal to 30 seconds. So x of car can be given as t square by 4 for 0 to 30 seconds. After that, at 30 seconds it has traveled 900 by 4 meters. So 900 by 4 plus the velocity into t minus 30. Same logic as above. So this will give 15t minus 225 for t greater than 30 seconds. Now we can find out when the two will meet by making a position versus time graph. So making the position versus time graph. So till 10 seconds, this is moving as t square by 2, which is the equation of parabola. T square by 2 till 10 seconds, and for car it is t square by 4. So it will be below this graph, because if you check at 10, t square by 4 will give a lower answer than t square by 2. So it will be lower in the y coordinate. This is x and this now. After that, the motorcycle is moving with this equation nt minus 50, which is equation of straight line. So let's make a straight line. This is still 10 seconds. Okay. And after 10 seconds, the car is still moving with t square by 4 position equation till 30 seconds. There can be two cases in this. The first case is that the car might intersect this graph before 30 seconds, or it might not intersect before 30 seconds. Something like this. Remember that before 10 seconds it cannot meet, except at origin obviously, because this graph will be always lower than this graph. Hope that makes sense. So we need to check which case is the actual case which is happening. For this we can equate the two equations, which is t square by 4 is equal to 10t minus 50. Taking the 4 on the other side, we will use the quadratic formula. This gives us plus minus root 800, which is 20 root 2, which is 10 plus minus 10 root 2. So we can see that no, this is 40 will be 20. So we can see that both times are either more than 30 or less than 10, which is this case. So this case cannot happen. So it must be this case. So that leaves us with this, that this is the situation that we have. Till 10 they are not meeting, till 30 they are not meeting. So after 30 the car moves with the equation 15t minus 225, which is straight line, and the slope is 15, which is greater than 10, which was the slope of the motorcycle. So they must intersect somewhere here, because the graph will be something like this. So we can equate those two equations to find the answer. This 15t minus 225 is equal to 10t minus 50. Will give 5t is equal to 175, which gives is equal to 30. So the answer is 35 seconds. The ninth question says a particle moves with uniform acceleration and v1, v2 and v3 represent the average velocities in 3 successive intervals of time t1, t2 and t3 respectively. Then so let's make a diagram. Okay, so this interval is t1, this is t2, this is t3, and it is given that it is moving with uniform acceleration. So let's write the velocity at each. Velocity at A will be 0. Velocity at B will be using V is equal to U plus AT. And assuming A as the acceleration, we will get the velocity at B to be AT1, AT1 plus T2. Here AT1 plus T2 plus T3. Okay. So let's calculate the distance in each interval, because we need to find average velocity, which is given by the distance in that interval divided by the time taken to cover that interval. So let's calculate SAB, which will be given by ut is 0, so half AT1 square, and SBC will be given by U is AT1, so AT1 T2 plus half A T2 square, and SCD is given by CD is given by A T1 plus T2, which is the velocity at C. multiplied by T3 plus half A T3 square. Using these equations, we can find V1, V2 and V3. So V1 will be half AT1, V2 will be AT1 plus half A T2, and V3 will be AT1 plus T2 plus half AT3. I have just divided this by T1, this by T2, this by T3. And now we need to find, so first let's find the difference, because so first let's find the sum of V1 plus V2 divided by V2 plus V3. So that will be half AT1 plus AT1 plus half AT2 divided by AT1 plus T2 plus half AT3 plus AT1 plus half AT2. So you can clearly see that none of the options will match, because there is 2T1 here and also 2T1 something. So these options are not matching. So let's focus on the difference options. So this will be half AT1 minus of AT1 minus half AT2 divided by V2 minus V3. So V2 is AT1 plus half AT2 minus AT1 minus AT2 minus half AT3, which will give us minus half AT1 plus half AT2 minus, this will cancel out, and this will give us minus half AT2 minus AT3 plus half AT3. So this is T1 plus T2 divided by T2 plus T3. So this is option B. So question 10 states that body is projected at an angle of projection theta with kinetic energy E. Neglecting air friction, the kinetic energy at highest point is. So it is projected at theta. Assume that the velocity is u, and so kinetic energy is given as E, which is half mu square. We know that at the highest point the velocity will become u cos theta, because there is no vertical component. So energy will become half u square cos square theta is equal to E cos square theta. So the answer will be D. So question 11 says a cannonball has a range r on a horizontal plane such that the corresponding possible maximum heights reached are h1 and h2. Then the correct expression for r is. So what this question is implying is that for the same range we can have two different heights, which basically implies that for the same range can be attained at two different thetas. So we need to use this fact. We know that range is given by u square sine 2 theta divided by g. So this implies that sine 2 theta will become equal at two different theta. Sine 2 theta 1 is equal to sine 2 theta 2. So 2 theta 1 must be pi minus 2 theta 2. This is the property of sine. So theta 1 is equal to pi by 2 minus theta 2. Okay. So we can get that the two angles will be theta and by 2 minus theta, for which we can have the same range. Hope this is clear. So now we know that height is given by u square sine square theta by 2g. So h1 is u square sine square theta by 2g, and h2 is u square sine square pi minus 2 theta 2g, which is u square cos square theta by 2g. Let's check the first option. 1 plus 2 by 2 is u square sine square theta plus u square cos square theta by 2g, which is u square by 2g, which is not equal to this range. So A option is wrong. And all the other options have h1, h2. So let's find out h1, h2 first. h1, h2 raised to power half, which is common in all three options. So this will become square root of u square sine square theta u square cos square theta by 2g, which will become u sine theta cos theta by 2g, and this has 2 theta, so we need a 2 here, right? So if we multiply this by 2, so this will cancel out, and if we multiply it by 2 once more, then it will become u sine 2 theta u square sine 2 theta by g. So we multiplied this by 4, so r is equal to 4 root h1 h2. Question 12 says a rigid body of length L is in contact with a vertical wall with its other end in contact with a horizontal floor. Point A moves with a constant velocity. The path along which the midpoint of the rod moves is. So we need to find the trajectory basically to comment on the shape of the path. And for trajectory, we relate the x and y component of the position. So let's find the x and coordinates of midpoint. We are given that this length is L. If we assume this angle as theta, so this angle will also be theta. So by this logic, the x coordinate will be L by 2 cos theta and L by 2 sin theta. So y coordinate will be L by 2 sin theta. So x is equal to y is equal to this, and we need to relate x and y. So basically we need to find the locus, and in cases where we have cos and sine, we usually square and add them to remove the cos and sine terms, so that we remove the theta variable. So x square plus y square equal to L square by 4 cos square theta plus L square by 4 sine square theta, which will become L square by 4. So this will become x square plus y square equal to L by 2 whole square. And this is basically the equation of a circle of radius L by 2, and center will be at origin because nothing is in minus with x or y, like x minus a, y minus b, a and b are 0. So answer will be option D. So next question, question 13 is a 12-mark question and it is a bit difficult. A car leaves point A for point B every 10 minutes. The distance between A and B is 60 km. The car travels at a speed of 60 km per hour. So the car will reach point B at in 1 hour. Determine graphically only the number of cars that a man driving from B to A will meet en route if he starts simultaneously from B. If he starts from B simultaneously with one of the cars leaving A. The car from B travels with a speed of 60 km per hour. Okay, so we can solve this question by drawing a graph. Let this be the time axis and let this be the distance displacement axis, and let A be at displacement 0 and B be at displacement of 60 kilometers. This. So a car leaves point A for point B every 10 minutes and car is also leaving B simultaneously with one of the cars leaving A. If we take first, I'm discussing the case which many people think is correct but it is actually wrong. Let's take this as 60 minutes. So the car leaving B will reach point A after 60 minutes. And car from A is also leaving simultaneously with B. It will reach after 60 minutes. And every 10 minutes, a car from A will leave for B. This will reach at 70 minutes. This will reach at 80 minutes. So on. It's a very rough graph. So let us count the number of intersections of both graphs. So 1, 2, 3, 4, 5, 6, 7. So many people answer the answer to this question as 7 cars, which is wrong. Because if we read the question carefully, then the question states that car from B is leaving simultaneously with one of the cars and not first car. So the question states car from A, car from B is simultaneously with one of the cars from A and not first car from. So we need to consider possible meetings car from B with cars from A that left before B. So let us draw the correct graph, which will be something like this. 60 minutes. Let this be point B, which is at 60 kilometers from A. So car from B is moving like this, and cars from A are moving like this, as we did before. But if we check at minus 10 seconds, which is 10 minutes before car from B is leaving, then it will also intersect car B's graph. It will reach B point 50 minutes after car B has left. Similarly for minus 20, minus 30, minus 40, and the car leaving 70 minutes before B cannot meet car from B because you can see the graph is not intersecting. So let us now count the number of intersections. 1, 2, 3, 5, 8, 10, 12, 13. Answer is 13. So question 14 says a person throws vertically up n balls per second with the same velocity. He throws a ball whenever the previous one is at its highest point. The height to which the ball's rise is. So if a person throws n balls in 1 second, the time taken by him to throw one ball is 1 by n second. And after 1 by n seconds, he will throw the second ball. And it is also mentioned that he throws a ball whenever the previous one is at its highest point. So 1 by n seconds will also be the time for one ball to reach the highest point. Which means that velocity will become 0 after 1 by n seconds. We will use v is equal to u plus 8a to find u. U is equal to g by n, and height can be given by square is equal to u square plus as. If 0 is equal to g square by n square minus 2g, so this will give the height as g by 2n. So the answer will become C option. 15th question says that a particle moves at a constant speed v from point A to point B along a circle of radius r. If points A and B have an angular separation of theta, the magnitude of change in velocity moving from A to B is. Let us understand this through a diagram. Let us choose the point A to be vertically above the center without loss of generality. So point A is here. B will be in I direction. This is I direction, J direction. So after theta, the point will be somewhere around here. Will be perpendicular. We need to find the magnitude of change in velocity. Also, Let us analyze point B. Point B is something like this. So this point, this angle will be theta due to alternate angles. So this will become 90 minus theta will become theta. So in this direction, in I direction, the velocity will be v cos, and downward direction it will be v sin theta. V final will become v cos theta I minus v sin theta j. The change in velocity will be v final minus v initial, which is v cos theta I minus v sin theta j minus of v in I direction, because v initial is v. So this will become v cos theta minus v cap is v sin theta of j cap. So to find magnitude, we have the formula that v1 plus v1 minus v2 is given by 1 square plus 2 square to v1 2, and we know that I dot j is 0, so this will be 0. This will become v square cos square theta plus square minus 2v square cos theta v square sin square theta, and these two terms will be sin plus cos, sin square plus cos square is 1, so we can combine these two terms, and the final magnitude will be v square plus v square minus v square cos square cos theta. So this will become 2 v square 1 minus cos theta. We can pull this outside, so this will become root 2v, and 1 minus cos theta, we know the formula that cos 2 theta is equal to 1 minus 2 sin square theta. So 1 minus cos 2 theta is 2 sin square theta. But here 2 theta is theta, so theta will be theta by 2. So this will become 2 sin square theta by 2, which will finally give us sin theta by 2, which is B option. Question 16 says a car moves with speed 60 km/h from A to B and then with 40 from B to C. Further, it moves from C to D with speed equal to average speed between A and C. All the points are equidistant and collinear. The average speed from A to D is. So let's understand with help of a diagram. All the points are equidistant. So let's assume the distance to be D. Speed from A to B is 60, from B to C is 40, and C to D is unknown right now. So the average from A to B will be D plus D, that is total distance by total time. D by 60 is time from A to B and D by 40 is time from B to C. That gives us 2 into 60 into 40 divided by 100. D and D will cancel out. So this gives us 48 km/h. and then V average from A to D is D plus D plus D, total distance, then total time. Speed between C and D is average speed of A and A to C, which is 48, and this comes out as 48. So the answer is C option. So question 17 is a 6-marker question from 2007, which says that let V and A be the instantaneous velocity and acceleration respectively of a particle moving in a plane. The rate of change of speed dv by dt of the particle is. So first let velocity, assume that the plane in which the particle is moving is the xy plane. So velocity can be broken down into two components. And speed is given by the magnitude of this velocity, which is vx square plus vy square plus 2vx dot vy. And since x and y are perpendicular, so this becomes 0. Now we need to find the rate of change of speed. So we have so we can square both sides, as we know that the square of modulus is equal to the square of vector. So if we differentiate this now, we get on cancelling 2. Also notice that v here is the speed, because we have squared the modulus, so this is speed. So basically this is not velocity, don't get confused. So rate of change of speed and not rate of change of velocity is equal to v dot a. So option B is correct, and this is also the component of a in the direction of v, we know from vector. So option C is also correct. So question 18 is a 12 marker from 2007, which says that a body of mass m is projected inside a liquid at an angle theta naught with the horizontal at an initial velocity v naught, something like this. If a liquid develops a velocity dependent force minus kv, where k is a positive constant, determine the x and y component of velocity at any instant and also find the range. First we'll break the velocity into x and y components. Let us analyze in the x direction first. In x direction we have the initial velocity as v naught cos theta naught I cap, and the force acting on it is avx in the minus I cap direction. So we can write fx is equal to minus kvx, which gives us mass into acceleration in x direction equal to minus kvx. Now we write acceleration as dvx by dt, which finally gives us dvx by vx is equal to minus k by m dt. Now we can integrate to find the component of velocity in x direction. We know that at t is equal to 0, the velocity is v naught cos theta naught, and at any random t we take it as vx, which gives us ln vx by v naught cos theta naught is equal to minus k by m t, which finally gives us Vx is equal to V naught cos theta naught e raised to power minus k by m to t. This was the analysis in x direction. Now let us analyze in y direction. In y direction, the initial velocity is minus v naught sine theta naught, and the forces acting on it are like this. So we can write that f of y is equal to kvy minus and this can be further written as m dvy by dt is equal to kvy minus mg. Now taking the dvy terms on one side and dt terms on one side, we get this, which can be integrated to find the vy. We know that at time t is equal to 0, the initial velocity was minus v naught sine theta naught, and at any time t we are taking it as vy. Integrating it, we find m by k ln of kvy minus mg divided by minus kv naught sine theta naught minus of mg is equal to t. So this will become kvy minus mg minus kv naught, or should I directly write it as minus kv naught sine theta naught minus mg e raised to power kt by m. So vy will be given as m by k g minus e raised to power kt by m k by m v naught sine theta naught plus g. So this is the analysis in y direction. It's a very mathematical question, but if you know how to do it, it is very easy. Now to find range, so I am assuming that they mean the range in x direction. So we can again write fx is equal to minus kvx, and this time we will write fx as m into vx dvx by dx. This is another form of writing acceleration. Is equal to minus kvx. So this will become m dvx by dx is equal to minus k, and this will further give us dvx is equal to minus k by m dx. Now we can integrate this. We know that when the x coordinate is 0, we have taken initial velocity as v naught cos theta naught, and I'm assuming that they mean that the range is when the x component of velocity will become 0. So I'm denoting range as r. This gives us minus v naught cos theta naught is equal to minus k by m multiplied by r, which finally gives us r is equal to m by k v naught cos theta naught. This is the answer for range. The 19th question says that acceleration time graph of a particle moving along x-axis is as shown. The particle will have same velocity as initial velocity at. So we know that the acceleration time graph, the area under the acceleration time graph gives us the change in velocity. So till t is equal to 10 seconds, the acceleration is positive. So the velocity will keep increasing. So let us find out the increase in velocity. So area under positive AT graph is given as, so since they have not given us this point, we'll assume it to be A. So the area will be given as 5 into A plus half into 5 into A, which is 15 by 2A. So the negative part should also have the area as 15 by 2A, or should I say minus 15 by 2A. So we need to find the time at which the negative area will also become 15A by 2. So let us analyze. Let this be x. So this is given as x minus 10, and let this be p. So we know that the slope of this line is same, so we can equate the slope. So also the area of this triangle will be and we can substitute the value of p from here, which will give us half into a by 5 into x minus 10 square, which is 15 by 2a. So cancelling this, it will give us that x minus 10 is equal to root 75, which is equal to, so this is 5 root 5, this is 5 root 3, so x is equal to 10 plus 5 root 3. Option C. Let Vt be the velocity of a particle at time t, then. So if this is the change in dvt by dt is the magnitude of change in velocity, and d of modulus of vt by dt is the magnitude of change in speed. So you can think of velocity as speed plus direction. Speed is the magnitude of velocity, and velocity also has a direction in addition to the magnitude, which is speed. So the rate of change of speed and rate of change of velocity are always equal. This is not true, because if the speed is changing and direction is also changing, then rate of change of velocity is not equal to rate of change of speed, because rate of change of direction is added to velocity. So option A is wrong. And option B says that rate of change of velocity and rate of change of speed may be equal. Yes, this is true. If direction is not changing, then both changes will be equal. Option C is that rate of change of velocity can be 0, while rate of change of speed can be 0, while rate of change of velocity is not 0. So if this is 0, then this can be non-zero if change of direction is non-zero. So option C is also correct. And option D says that if that rate of change of speed is non-zero, then that implies that rate of change of velocity is also non-zero. That is true, because if this is non-zero, then this will also be non-zero. But D is also correct. So question 21 says that velocity displacement curve of a particle moving in a straight line is as shown. Line PB is normal to the curve and line PA is normal to x-axis. The instantaneous acceleration of particle P is. So we are given velocity and displacement and we have to find acceleration. So we know the relationship. So velocity we have as 4, but dv by dx we are not given. But we are given the slope of the normal. And we know that normal is tangent to the normal is perpendicular to the tangent. So we can calculate the slope of tangent from here. So first let us calculate the slope of normal. So that is given by 4 by, so that is minus 4. And we know that the normal is perpendicular to tangent. So the slope of normal and the slope of tangent should be equal to minus 1. So we get that the slope of tangent is minus by minus 4. So this is 1 by 4. So we can calculate the acceleration now, which is 4 into 1 by 4. This was dv by dx, which is 1 meter per second square. So this gives us C. So question 22 says that the graph shows the displacement of a body as a function of time. Which of the following are conclusion? So we can see that the body is coming to rest, as let us analyze the slope. First the slope is like this and slope is like this. Slope is finally becoming parallel to x-axis. So here theta is, let's say the theta is 70 degree. It is becoming 60 degree, then 40, and finally it will become 0 degree. So we know that tan of 0 is 0, which is also the slope of this graph. Tan is the slope of this graph, right? So and slope of the graph is also equal to velocity. So velocity is becoming 0, and initially the velocity was more than 0. So we can conclude that it is a retarded motion, and since the velocity is becoming 0, then body is coming to rest. It cannot be accelerated motion, and the graph represents motion with constant velocity. No, because the slope is changing. Answer is C and D. Question 23 says bamboo strips are hinged to form 3 rhombi as shown. Points A0 is fixed to a rigid support. The length of the sides of rhombi are in ratio 3:2:1. Point A3 is pulled with speed V. Let VA1 and VA2 be the speeds of A1 and A2. Then the ratio of VA1 is to A2 is. So we already solved a question like this where we wrote the coordinates of the joints. Again, we are going to do the same thing. So we can assume the length to be 3L, 2L and 1L because it is given 3:2:1. So I have taken the constant L, and we have also taken the angle to be theta. Okay, so we can write the coordinates of A1 as 6L cos theta, comma 0, A2 as 6L cos theta plus 4L cos theta, comma 0, A3 as 6 plus 4 plus 2L cos theta 0. And if we differentiate, then we will get the velocity of A1, A2, A3. And finally, we will reach the conclusion that this is equal to the summation of length. So we are asked VA1 by VA2. So that is L1 by L1 plus L2. And that gives us 3L by 3L plus 2L, which is 3 by 5. So we'll get the answer as option B. Okay, so 24 question is a decent question. Two particles are moving along x and y axis towards the origin with constant speeds u and v respectively. At time t is equal to 0, the respective distances from the origin are x and y. The time instant at which the particle will be closest to each other. So I will teach you three methods for this question. Method 1 is a very mathematical method. So let us draw the x and y axis. So we are given that at t is equal to 0, this particle is moving with u, this particle is moving like this with v, and the velocities are constant. So at any time t, the position can be given as u sorry, this position is x comma 0 and this position is 0 comma y. So at any point t, this particle will be at x minus ut comma 0, and this particle will be at y minus vt, and the distance between them has to be minimized. So we can write the distance as x minus ut square plus y minus vt square, squaring, we get x minus ut square plus y minus vt square. Now we can differentiate and equate it to 0 to find the time at which the distance will be minimum. It will become this should be equal to 0. So we'll get, let's cancel 2 from both sides, and so this should be ux minus u squared t minus vy, this will be plus v squared t is equal to 0. So t will come out as ux plus vy divided by u square plus v square. So this is the first method, which is very mathematical. The two methods are related to physics, the remaining two methods. So this will be using relative motion. So let us draw the situation. Let us name this particle A and let us name this particle B. So we have, and this is origin O. So R, A, O. This means that the position of A with respect to origin is x, 0, initial position. We'll write t is equal to 0. And the velocity of A with respect to origin is minus u, 0. Similarly, the position of B with respect to origin at t is equal to 0 is given as 0, y, and velocity of B with respect to O is given as 0, minus v. So now I'll be going into the frame of A. So now let us go into the frame of A. So A is here and B is somewhere here. So the position of A with respect to A will obviously be 0, 0, and velocity will also be 0, 0. So essentially we have transferred A to origin and we have fixed A. It is not moving. And position of B with respect to A at time is t is equal to 0 can be given as minus x, y, and velocity of B with respect to A can be given as u, minus v. Okay. So what does RBA mean? B is moving with u velocity and minus v velocity. So it is moving like this, and assume A to be somewhere around here, and the minimum distance will be when this line is perpendicular to the motion of particle B. We know this by straight line. So what does RBA mean? At t is equal to 0, RBA is this. At some random t, it will become this. And at time of minimum approach, this will be this. So we can see that the velocity of B will be perpendicular to the RBA at time of minimum of approach. And we can write RBA at any time t as RBA t is equal to 0 plus relative velocity into t. This is nothing but s is equal to ut plus s naught. This is initial position and this is ut. As since we are in relative frame, so we are using vrel. So I can write this as minus xy, since we check that RBA at t is equal to 0 as minus xy. So, and vrel is equal to ut minus vt. So this will become minus x plus ut y minus vt, and we know that RBA t minimum approach dot velocity of B rel is equal to 0 since they are perpendicular. This gives us which will give us time as xu plus vy divided by u square plus v square. This was the second method. And now for the third method, it is also based on relative approach, but it is a bit more mathematical than method 2. Again, we are fixing point A. So we will add the velocity u in opposite direction as point A, and point B already has v in minus j direction. So it will be moving like this, right? And this slope will be given as tan inverse of, no, slope will be given as minus v by u. So we can write the equation of this line as, since this is at 0 comma y and this is at, we don't know this point, so we will write as no, this is the variable and this is what we have already been given, and this was minus 0, so I have not written that. So this is the equation of this line, and this line will be perpendicular to this line. This line will be perpendicular to this line. So the slope will be negative inverse of minus v by u, which is u by v. So we can write it as, since this coordinate is x comma 0, we can write it as, so we need to find the intersection of these two lines. We will find only the x coordinate of the intersection because we know the velocity of b in x direction, which is u. So we can find the time using that. I'll show you how. So I am substituting this y into this y. So this will become, which will further give us x will give us vy plus ux divided by y into u square plus v square multiplied by uv, and we can cancel v. This will be okay. So x coordinate of this point is given as this. Sorry, I forgot a u. And we know that the velocity of b in x direction is u. So, and initial velocity is 0. So we can get, no, initial position is 0. So s is equal to ut is equal to so time of approach is given by, which is same as the above two methods. So question 25 is a 6-marker question which says that a particle q is moving along y-axis. Another particle p is moving in the xy plane along a straight line x is equal to minus d with a uniform speed v parallel to that of q. At time t is equal to 0, particle p and q happen to be along x-axis whereas a third particle r situated at x is equal to plus d comma 0 starts moving opposite to 3 with a constant acceleration a. At all further instant, the three particles happen to be collinear. Then, okay, so since at all further instants the three particles happen to be collinear, we need to write the position of all three particles at any instant. So this is moving with velocity v in the y direction. So at any random t, it can be given as minus d comma vt. And since we do not know the speed or acceleration of q, we can assume it to be 0 comma y, since it is moving along plus y, we know that, and it is moving in the minus y direction with constant acceleration a. So this can be given as d comma minus half at square. So these are the three coordinates of the particles at any random time t, and it is given that these 3 points are collinear. So we know that when 3 points are collinear, the area will be 0. So we can calculate the area by area of triangle formula. I'm using shoelace formula. So this gives us minus dy plus dvt minus of yd plus half dat square is equal to 0. So this gives us y is equal to v by 2 t minus of 1 by 4 at square. So this is something like the formula s is equal to ut plus half at square. We can convert it into that formula by writing it in this manner. So we get that the velocity of particle r is v by 2 initial velocity, and it has acceleration minus a by 2. So we need to find when it will come to rest. So at rest the final velocity will be 0. So using v is equal to u plus at, we have so we get time is equal to v by a. Then we need to find when it will return to its initial position. So for returning to initial position, the displacement will be 0 and initial velocity is v by 2 and 1 by 4 at square is equal to 0. So this will give us time is equal to 2v by a. So option D is also correct. So answer is A, B, C, D. Question 26 says that a particle is moving in a positive x direction with its velocity varying as v is equal to alpha root x. Assume that at t is equal to 0, the particle was located at x is equal to 0. Determine the time dependence of velocity, acceleration, and the mean velocity of particle averaged over the time that the particle takes to cover first s meters of the path. Okay. So we can write it as v is equal to alpha root x, and if we square, we get v is equal to alpha square x square alpha square x, and it is of the form v square is equal to u square plus 2as. We can write it in that form. So we get that the acceleration is alpha square by 2, and from here we can calculate the time dependence. Since initial velocity is 0, we get from here, so v is equal to u plus at. So this will be the time dependence. Then we need to find the mean velocity of the particle averaged over the time that the particle takes to cover s. So s is equal to ut 0 half a t square. This gives us t is equal to 2 root s by alpha. So mean velocity will be given by s by 2 root s into alpha, root s alpha by 2. This will be the velocity of mean velocity. Question 27 says a particle moves in a plane with a constant speed along a path y is equal to 2x square plus 3x minus 4. When the particle is at 0 comma minus 4, the direction along which it is inclined is to the x-axis is. So I'm drawing the random trajectory. Assume that at 0 comma 4 minus 4 it is here. So it will be moving this way, which is the slope. So we need to find the slope of this equation, which is, and at 0 comma minus 4 it will become 3. So the tan theta is equal to 3. So theta is equal to tan inverse 3. NSEP allows calculator and you will get the answer as 72 degrees approximately. Question 28 says that two particles A and B are moving in xy plane. Particle A moves along a line with equation y is equal to x, while B moves along x-axis such that x coordinate of A and B are always equal. If B moves with uniform speed 3 meters per second, then speed of A is. Assume this is the xy plane. So B is moving, sorry, B is moving along the x-axis at 3 meter per second, and A is moving along y is equal to x. And we know that slope of y is equal to x is 45 degrees. So A is moving along this. Assume it has velocity v. So the position of A is x comma y, then that will imply that position of B is x comma 0. So the speed of B in x speed of B, which is dx by dt, it should be equal to the x component of speed of A. That means that VA cos 45 should be 3. That gives us V is equal to 3 root 2. Question 29 says that a plane mirror coincides with a plane having equation x is equal to 3. A particle is moving along a line with direction ratios 3 is to 4 is to 5. If speed of particle is root 2, then velocity of its image is. So assume this is the y coordinate, this is x, and z is in this direction. So the plane is here at x is equal to 3, and we have a line with direction ratios 3 is to 4 is to 5. So we can find the unit vector of this line by doing this. If the direction ratio is this, then unit vector will be given by first we need to find the magnitude, which is 9 plus 16 plus 25 root 50, which is 5 root 2. So this will be 5 root 2i plus. So this is the direction in which the particle is moving, and the magnitude of this velocity is root 2. Assume that it is moving along this direction. So the particle will have the components as this, and after it reflects, the components will be like this. If you notice, then only the x coordinate has changed direction. So we can write the velocity after reflection as, we add minus sign in front of I cap, and rest of the components remain same. So that will be given by option D. A body released from a height h hits elastically an inclined plane at a point P. After the impact, the body starts moving horizontally and hits the ground. Height at which point P should be situated so as to have the maximum travel time. So first we need to establish that when body is dropped with no initial velocity and covers the height h, then it will take h by g time. With this established, let's move on to the solution. Let the incline be like this. Let the particle be here at a height h, and let this height be h. So the total time of travel will be plus because here also the particle is moving horizontally and does not have any vertical velocity. So this will remain the time. So now we need to find the height for which the total time will be maximum. With respect to h, we get this will be minus. Let's cancel out the common. This will give us so this implies that h is equal to h by 2. So h minus h, which is the answer, is also h by 2. So the 31st question says that a car moving along a straight road at a speed of u meter per second applies a brake at t is equal to 0 second. The ratio of distance traveled by the car during 3rd and 8th second is 15:13. The car covered distance of 1 by 4 meter in the last second of its travel. Therefore, the acceleration and the initial speed is. So we know that the distance traveled in nth second is given by u plus a by 2 multiplied by 2 into n minus 1. So distance in third second is given by u plus 5a by 2, and distance in 8th second is given by u plus 15a by 2. So we know the ratio is given as 15 by 13, which means 13u plus 60a by 2 is equal to 15u plus 225a by 2. So this implies that 2u is equal to minus 165a by 2. Sorry, this will be 65a. This will be minus 160 by 2, which will imply that u is equal to minus 40a. From here we can calculate the total time the car takes to come at rest. So v will be 0, so v is equal to u. We should write u as minus 40a plus 80, which will give 40 seconds as time taken by car to stop. And we know that the car covers a distance of 0.25 meter in the last second. So S40 is 0.25, which is minus 40 plus a by 2 into 79, which gives us acceleration is equal to minus 0.5. So only C option has minus 0.5 as acceleration, and you can easily calculate speed also by multiplying it by minus 40. Question 32 says that two particles A and B are situated 10 meters apart along x-axis, B being further off A at t is equal to 0. Particle A is moving at 0.75 meter per second parallel to y-axis, while particle B is moving 1 meter per second along minus x-axis. After a time t, they both come close to each other. So, therefore, the time t is. So we'll use relative motion by fixing B. That will give A 1 meter per second in I direction. It will move along this direction, and tan theta will be, the slope will be 3 by 4. So when this will be perpendicular, this line will be perpendicular to the velocity of A, then the distance will be closest. So we can find the time taken to cover this distance by this formula. We know that this distance is 10, so this distance will be given by 10 cos theta, and velocity is 1 plus 3 by 4 whole square, and this is tan theta. So cos theta is 4 by 5, so we get 10 into 4 by 5 by 1 plus 9 by 16. So this gives us 6.4 seconds as the answer. So question 33 is asking for the correct acceleration time graph corresponding to velocity time graph. So from here to here, the change in y is 2, and also the change in time is approximately 1. So the acceleration should be 2 till t is equal to 1. So this is wrong, this is wrong. These two might be correct. And till 1.75, the acceleration is 0, which is correct in both C and D. And after that, the acceleration becomes negative and it is constant. But here the acceleration is changing at 2.5, but it should remain same. So D option is also wrong. So answer is C. Question 34 says a particle moves in xy plane according to the relation x is equal to kt and y is equal to kt 1 minus pt, and they are asking for the trajectory. So whenever trajectory is asked, it means that we have to relate x and y and eliminate all other variables. X is equal to kt and y is equal to kt 1 minus pt. So from here we can get that time is equal to x by k. It is easier to get time from this equation than this equation, so we will put time from this equation to this equation. So y will become k into x by k 1 minus p multiplied by x by k, which gives x minus px square by k is equal to y. And since this resembles the formula of a parabola, the answer to 34 will be A is correct, and they are also asking for other parts. So the particle has constant velocity along x-axis. So constant velocity along x-axis will be given as dx by dt, which is k, which is constant. It is given that k is constant. So option B is correct. The force acting on the particle remains in same direction even if both k and p are negative. Since velocity is constant in x direction, so acceleration will be 0. That means that there is no force in x direction. Now in y direction, the velocity is given by a minus of 2 kpt, and acceleration is given by dvy by dt, which is minus 2 kp. Now if both become negative, then also the answer will be minus 2 kp, because negative into negative will become positive. Option C is also correct. And acceleration along y-axis is minus 2 kp, and since k and p both are constant and there is minus sign also, so the acceleration is constant in minus y-axis. So ABCD is the answer. Question 35 says a man is going up in a lift moving with constant velocity 3. He throws a ball up at 5 meters per second relative to the lift when the lift is 50 meters above the ground. Height of the lift when the ball meets it during its downward journey. So this is a lift and a person throws a ball upwards at 5 meters per second relative to the lift. So the lift is at rest. So we can find when the ball meet the lift again, if the lift is at rest, because this is relative velocity. So the displacement will be 0 and u is 5j. Time we have to find, and acceleration is minus 10j t square. So this means that 5 is equal to 5t. This implies t is equal to 1 second. Now we need to find the height of the lift when the ball meets it during its downward journey. So the lift will move. We have to find how much will the lift move in 1 second. So the velocity of lift is given as 3 meters per second and it is constant. So S is equal to ut. So 3 into 1 is equal to 3 meter, and it is already 50 meter above the ground. So height of the lift will be 50 plus 3 meter, which is 53 meter. Question 36 says a particle moves according to the law x is equal to at and y is equal to at1 minus alpha t, and these are constants and t is time. The time instant at which velocity makes an angle 45 degrees with acceleration. So x is given as at, which implies vx is dx by dt, which is a. This implies ax is equal to 0 because velocity is constant, and y is given as at1 minus alpha t, which implies vy is equal to dy by dt, which implies vy is equal to a minus 2a alpha t, which implies ay is equal to dvy by dt, which is minus 2a alpha. So the acceleration is constant in the minus y direction, and the velocity is a in this direction and a minus 2a alpha t. So this needs to make 45 degree with the minus y direction. That means that since this angle is also 45, so perpendicular by base is equal to tan 45 is equal to 1 is equal to perpendicular by base. That means perpendicular is equal to base, and since the base is made by the x component of velocity and perpendicular is made by y component, then both the components should be equal. So that implies that a is equal to a minus 2a alpha t, which means that since this is in y direction, it should be minus. So that means that 2a is equal to 2a alpha t, so t needs to be 1 by alpha. So question 37 says that the velocity of a projectile at highest point of its trajectory is 0.4 times of its velocity at point at half its maximum height. The angle of projection is. So assume that we are projecting the particle with u velocity at angle theta, then the velocity at maximum height will be u cos theta. This is a well-known fact. So we need to find what will be the velocity at half height. So we know that the time taken to height, the time taken to reach maximum height is given by u sin theta by g. Height is given by two g. So half height will be u square sin square theta by 4g. So that means that the velocity component will become, using v square is equal to u square plus 2as, so this will become v sin theta by root 2 at half height, and vx is constant, so vx at half height will also be v cos theta. So the magnitude of velocity at half height is given by v square sine square by 2 plus v square cos square, and we are given that this is root 0.4 times of the velocity at maximum height, which is v cos theta. So squaring both sides, we will get which will give us 2 by 10 v square sine square is equal to 6 by 10 v square cos square, which gives us tan square is equal to 3, tan is equal to tan theta is equal to root 3. Sorry, I have omitted theta many times. So theta is 60 degree. Question 38 says an aircraft flies at a speed v from city A to city B from and back in time t naught. City B is to the east of city A at a distance d. The aircraft takes time t1 for the round trip if wind blows with speed w along AB, and time t2 if wind blows with same speed perpendicular to AB. Then basically there are three cases. A and B have distance d between them, and the plane has speed v. So if no wind is blowing, then the time will be 2d, the to and back distance, by v. Now second case says that a wind is blowing in the direction from A to B. So T naught will be given. When the plane is going from A to B, then the wind W is in same direction as wind V. Speed of the plane V. So W will help V reach the point B faster. So time will be given by D divided by V plus W. But when the plane is returning, V is in minus I direction, but W is in plus I direction. So it will become, which becomes 2dV divided by V square minus omega W square. Now the case 3 is a bit tricky. It says that the velocity is perpendicular, velocity of wind is perpendicular, so the plane cannot move in plus I direction, because if it moves in plus I direction, then the perpendicular velocity W will deviate it and it will go along this path. It cannot move along AB in plus I direction, so it must move a bit downwards, so that the V sine component is equal to W, so that both get cancelled out. That gives us V sine theta is equal to W, which gives us sine theta is equal to W by V. And if this is theta, then the triangle will be like this. Base will be V square minus omega square W square. Now the time taken will be 2d by V cos theta, because the velocity in the direction of AB is still V cos theta, right? And cos theta can be obtained from the triangle. It will become, so we have got T naught, T1 and T2, and now we need to compare the three. So T naught is 2d by V, T1 is 2dV by v square minus omega square, and t2 is equal to 2d v square minus omega square. But to compare fractions, either the numerator should be equal or denominator should be equal. So I am making the denominator equal by taking LCM. Okay. Further, I am writing T naught as 2D no leave it. Since the denominator is equal, so we know that v square minus omega square root is less than v, and v square minus omega square is also less than v square. So t1 will be the greatest, then there will be t2, then there will be t naught. To compare t2 and t1, you can see that you can take any example. You can choose v and w as like 2 and 4, and you can calculate, because it should hold for all values. So you will get that t2 is greater than t naught. So the answer will be B option. So question 39 says that projectile is fired from ground with velocity u at an angle theta with the horizontal. It would be moving perpendicular to its initial direction of projection after a time t. So assume that the particle is, it is given that the particle is thrown with velocity v u at theta angle, and we need to find the instant when the velocity will become perpendicular. So the v at any time instant can be given as u minus of gt and u cos theta, sorry, u sin theta minus gt, because the x component never changes of velocity in projectile motion, because there is no force in x direction. So we know that u is perpendicular to v, so the angle between them is 90 degree. That implies that dot product should be 0, and that implies that u cos theta, u sin theta dot product with u sin, sorry, I took the velocity wrong. So taking the dot product, it will become, I hope you know how to take dot product. So this should be equal to 0. So from here we get that the time is u by g sin theta. So the answer will be the option. But I would like to add a note that it is not necessary that this time must be less than the time period of the flight. It is possible that this time can become more than the time period, so the velocity will never be perpendicular, because the particle will hit the ground before the velocity becomes perpendicular, and that will happen when this is greater than 1. This implies that this becomes greater than 1, which basically implies 2, which implies sine square theta is less than half, which implies theta is less than 45 degrees. So when theta is less than 45 degrees, then the time to make the velocity perpendicular to initial velocity is more than the time period of flight, so the velocity will never be perpendicular. This question 40 is asking for the trajectory of the particle. So whenever the question asks for trajectory, we relate the x and y component. So we are given r, which is basically xi plus yj. It is given as ati plus bt square j. So x is equal to at and y is equal to bt square. We are comparing the I cap and j cap coefficients. So from here we obtain t is equal to x by a. So we can substitute t here. That will become this, which is the equation of a parabola. Question 41 says that an observer stands on a platform at the front edge of the first bogie of a stationary train. The train starts moving with uniform acceleration and the first bogie takes 5 seconds to cross the observer. If all the bogies of the train are of equal length and the gap between them is negligible, then the time taken by the 10th bogie to cross the observer is. Okay, so we are given that the train is moving with uniform acceleration. So assume the acceleration to be a, and the train starts moving with uniform acceleration and first bogie takes 5 seconds to cross the observer. So assume the length of the bogie to be L. So it will be S is equal to ut plus half at square, and since u is 0, it will become half into a into 5 square, which is 25a by 2. Now the time taken by 10th bogie. So the time taken by 10 bogies, not the 10th bogies. 10 bogies will have length 10L, and it will take half into a into t square time, which gives us t as root 20 L by a, and 9 bogies will take 10L, and 9L is equal to half 80 square, which gives us t as root 18L by a, and we are asked the time for the 10th bogie to cross. So that will be time taken by 10 bogies minus the time taken by 9th bogie, 9 bogies. So that will give us, if this is t1 and this is t2, so time will be t1 minus t2. So root 20L by a minus root 18L by a, and we use this relationship that L is equal to 25a by 2, and finally we get the answer as 0.81 seconds. So option D is the correct. Question 42 says, in the following figures, the velocity time graph for 3 particles 1, 2 and 3 are shown. The magnitude of average acceleration of 3 particles over 10 seconds has the relationship. So for finding the average acceleration, the formula is v final minus v initial divided by time. So we are only concerned with the final and initial velocities. So for 1, the average of first particle is, final velocity is minus 2 and initial velocity is 0, and time is 10 seconds. That gives us minus 2 by 10, and since we are asked the magnitude, so it will become 2 by 10. For second particle, the average acceleration is final velocity is 0 and initial velocity is 2. So 0 minus 2 by 10 is also equal to 2 by 10. And for third particle, the final velocity is 2 and initial velocity is 0. So it is also 2 by 10. So the answer is 10. Option D. Question 43 says a particle is projected from the ground with a velocity 3I plus 10j meter per second. The maximum height attained and the range of the particle are. So for finding the maximum height, we are only concerned with the velocity in j direction, which is 10j. And we know that at maximum height, the final velocity will be 0. This is u. And v will be 0 at maximum height. So we use v square is equal to u square plus 2as, which gives us 0 is equal to 100 j cap plus 2 into minus 10 j cap into h max. So h max comes out as 100 by 20, which is 5 meter. So option A is correct because only this has the maximum height at 5 meter. I'll also find out the range. So the time taken to cover the range will be double the time taken to cover the maximum height. So we'll first find out how much time was taken to cover the maximum height. So S is equal to ut plus half at square. 5 is equal to 10 into t minus half into 10 into t square, which gives us 10t minus 5t square is equal to 5. So 5t square minus 10t plus 5 is equal to 0, which gives us t square minus 2t plus 1 is equal to 0, which is the square of t minus 1. So t comes out as 1 second. So time taken to cover the range is twice of 1 second, which is 2 seconds. So range is equal to ut, which is 3 into 2 is 6 meter. Since the horizontal velocity is 3I cap, so range is 6 meter, which matches with option A. Question 44 says a shot is fired at an angle alpha to the horizontal up a hill, which is considered to be along a straight inclined plane of inclination beta to the horizontal. It will strike the hill horizontally if. So a shot is fired with inclination alpha to the horizontal up a hill which is at an inclination beta. It will strike the hill horizontally. So when it hits the hill, it has only horizontal velocity, which is possible if this point is the maximum height of the projectile at angle alpha. So consider initial velocity be u, and this point will be the maximum height of this projectile, and we know that maximum height is at half of range in horizontal direction, so this will be r by 2. From here we use the formula that we already know for h max and range. So this will become h max is given by u square sine square alpha divided by 2 into g, and half of range will be half u square sine 2 alpha multiplied by g. So g and g get cancelled, 2 and 2 get cancelled, u square gets cancelled. So we get tan beta is equal to sine square alpha divided by sine 2 alpha, which further gives us, we can write sine 2 alpha as 2 sine alpha cos alpha, and cancelling out one sine, so this gives us tan beta is equal to tan alpha by 2, which gives us option A. Question 45 is a bit tricky. A ball is projected from horizontal ground. It attains a maximum height h on its projectile path and thereafter strikes a stationary smooth vertical wall and falls on the ground vertically below the point of maximum height. Assume the collision with wall to be perfectly elastic. The height of the point on the wall where the ball strikes is. So let's understand this with the help of a diagram. Let the initial velocity be u and it is projected at an angle theta. So it will attain the maximum height h, and then after moving some distance it strikes a wall. And then it falls vertically below the point of maximum height. It falls finally here. Okay, and the collision with wall is perfectly elastic. So the collision will be something like this, that the ball is coming in this direction and it has some velocity in the horizontal direction and some velocity in the downwards direction. And if the collision is perfectly elastic, then the vertical velocity will remain same and the horizontal velocity will get reversed in direction and the magnitude will be same. So we know that if there was no wall, then the projectile would have completed the whole range if there was no wall. But since it is hitting the wall, it will move somewhere here. And since the horizontal velocity has only changed the direction and vertical velocity is same, so we can conclude that this distance and this distance will be same, and this distance was given to be r by 2 because the ball is falling directly below the maximum height and maximum height is at r by 2 distance from starting. So we conclude that r by 2 plus 2x must be the range. So that gives us that x is equal to r by 4, which gives us the x coordinate of the wall as r by 2 plus x which is 3r by 4, and we know that the equation of a trajectory of projectile motion is given as x tan theta 1 minus x by r. So from here we first obtain a relation between the maximum height and the range, which is h is equal to r by 2, since maximum height is obtained at r by 2, tan theta 1 minus r by 2 divided by r, which gives us r tan theta by 4. And for the wall, now we can write that 3r by 4 is equal to, no, we need to find the y coordinate of wall. So is 3r by 4 tan theta 1 minus 3r by 4 divided by r. So this will give us 3r by 4 tan theta multiplied by 1 by 4, which is 3 by 16 r tan theta. So now we have that r tan theta by 4 is equal to h. So we can use that here. We can write this as r by 4, 3 by 4 multiplied by r tan theta by 4, which is 3 by 4 h. Question 46 says, a sphere of mass 2 grams is released from rest in a large cylindrical vessel filled with oil. The resistive force due to viscosity of oil acting on sphere is proportional to its velocity. Okay, so mass is 2 grams, mg is acting downwards, and resistive force will act opposite to velocity. Proportionality constant I have taken as k. They are saying that the terminal velocity of sphere is 5 centimeter per second, and they're asking for the time it takes the sphere to reach 90% of its terminal velocity. So we can write force on this particle is mg minus kv, which gives m dv by dt. Mass into acceleration is minus kv. Now rearranging terms, we get we can integrate this equation to find v. So we know that at t is equal to 0 the sphere was at rest, released from rest. So at the velocity was also 0, and at any time t I'm taking the velocity as v. So on integrating we will get minus 1 by k log of mg minus kv divided by mg is equal to t by m. From here we will get mg minus kv equal to mg raised to power minus t k by m, and velocity will be mg minus t raised to power t by m multiplied by 1 by k. So taking out the common terms, we will get t is equal to mg by k multiplied by 1 minus t raised to power minus tk by m. Okay, so now they have given one more information, that the terminal velocity of the sphere is 5 centimeters. So terminal velocity is achieved when both the forces are equal in opposite direction, so that no force is acting. So that is the definition of terminal velocity. So k terminal velocity is equal to mg. Both the forces should be equal. Terminal velocity is basically mg by k, and we are also given the value of vt. So here we can substitute mg by k as terminal velocity. And we need to find the time when the velocity will become 90% of terminal velocity. I'll write this as 9 vt by 10 equal to vt 1 minus s dash time. T dash is the time that we have to find. Now this will become e raised to power minus t dash k by m is equal to Vt by 10. This means that time will be dash minus k by m is equal to, sorry, there was Vt here also, so Vt will get cancelled. It will become minus log of 10. We can cancel minus on both sides. Now we need to find k by m, and k by m we can find from this equation. So we know that Vt we know and g also know. So this will be m by k. So we need to find k by m, which is g by Vt, which will be 9.8 divided by, how much was the terminal velocity? So 5 centimeter per second. This will be 5 into 10 raised to power minus 2, which will basically give us terminal velocity as 190, no, k by m as 196 second inverse. So now we can substitute k by m here. So it will become 196 dash is equal to, log 10 is 2.3. So we will get dash equal to 2.3 divided by 196 is 11.7 milliseconds. 11.7 milliseconds is correct. Now question 47 says a particle moves along a straight line. Its displacement s varies with time t according to the law s square is equal to at square plus 2bt plus c. And they're asking for acceleration. So this question is very similar to the first question that we solved. That came in 2003. So they repeated similar question in 2022. Let's see. S square we are given and we need to find the acceleration. So we will start by differentiating this equation. So 2s ds by dt is equal to 2at plus 2b, and we can cancel 2. Now ds by dt is v, so we can write v as at plus b by s. Need to find acceleration, so we will differentiate this one more time. Now while differentiating this we need to be careful. Become a by s, and now I'm differentiating s, so this will become minus 1 by s square at plus b, and don't forget the ds by dt because we are differentiating in terms of t and not s. It will become as minus at plus b multiplied by velocity divided by s square. Velocity we can substitute from here, so this will become as minus at plus b whole square divided by s square. Now taking the LCM in numerator, this will become s square minus at plus b whole square divided by s cube. Now adding the square we will get whole divided by s cube So now we cannot comment on proportionality because t is also here. So we need to remove t, and for doing that we can use the original equation. So we can see that if we take a common from some term, a bt square plus 2bt plus b square divided by s. So we can see that this term in the bracket is equal to this. So this can be written as s square minus c. So writing a square minus a, s square minus c minus b square by s. So this will give us ac minus b square divided by s cube. So we can see that acceleration is proportional to 1 by s cube, is s raised to power minus 3. So the answer will be D option. Question 48 says, two balls are projected from top of a cliff with equal initial speeds u. One starts at an angle theta above the horizontal while other starts theta below the horizontal. Difference in the range. Okay, so assume the cliff is at a height h and one particle is thrown above the horizontal with theta and one particle is thrown below the horizontal with theta. So either you can calculate the range in the traditional way by using equation of motion, but I'll tell a better method. So this particle will be traveling something like this, and this particle will travel like this. So once it reaches the same level as the initial level, it will start moving with, this was moving with u and this was also moving with u. It will start moving with u with theta below the horizontal. We know this from projectile motion and it can be easily proved because Vx component will remain same, and here the vertical velocity was 0 and the gravity will make it equal to the initial vertical velocity but change the direction. So this particle and this particle are moving with same speed and theta. This will also move like this. If this is the range of the above particle till it comes to the same initial level, and this is x, so this will also be equal to x because both are same initial speed and theta. So we need to find this delta r, right? And we know that this is r from above. So delta r will be equal to r minus x, which is this, and plus x. So this is equal to r of this range of this particle, and we know that range is given by u square sine to theta by g. Answer will be option C. Question 49 says, two equal blocks each of mass m hang on either side of frictionless light pulley with a light string. A rider of mass m is placed on one of the blocks as shown. When the system is released, the block with rider descends at a distance h till the rider is caught by a ring that allows the block to pass through. The system further moves a distance of d in time t. So the acceleration due to gravity is r. First, we will calculate the acceleration before the rider is stopped by this loop. Equation of we will write equations. I am writing for this combined system first. M plus mg minus of tension is equal to m plus m into acceleration, and for this m will be t minus mg is equal to ma So from here we will find out that if we add both the equations, we will get mg is equal to 2m plus m, which gives us acceleration as mg by 2m plus. So with this acceleration, this combined system is moving a distance h before this thing gets caught by the loop. So we need to find the velocity till here so that we can then calculate d. So velocity after moving distance h with this acceleration will be v square is equal to, since u is 0, so 2 mg 2m plus multiplied by h. So velocity will be 2 mgh 2m plus m, and with this velocity it is further moving a distance d in time t. So using this formula that v is equal to by t, we will get v is equal to mgh divided by 2m plus m multiplied by t. So we need to find g, so we will square on both sides. So from here we will get that g is equal to 2m plus m multiplied by d square divided by mh t square. So this is given by option A. Question 50 says a balloon initially at rest rises from the ground with a constant acceleration g by 8. When its height is h above the ground, a packet is dropped from it. The time taken by the packet to reach the ground. So the velocity of the balloon when it is at a height h will be, we can find it by v square is equal to, since it is rising from rest, so 0 plus into g by 8 into h, which will give us the velocity as root ph by 2. So now we need to find the time the packet takes to reach the ground. So the packet is at a height of h, and this is packet and ground is here. It is at a height h and velocity is g by h by 2 j cap. So we can use s is equal to ut plus half at square. S is minus h j cap, u is root h by 2 j cap multiplied by t plus half minus g j cap square. So now this will give us minus 2h is equal to root gh t minus gt square, which will give us gt square minus root gh t minus 2h is equal to 0, and we need to find time, so we will use quadratic formula. This will give us root h plus minus of will be 8, so 8 plus 1 9, 3 root h by, so if we take minus then time will come as minus, so we will take plus, which will give us h by g. So this is root h by g, option D. Question 51 says a ball is projected at an angle alpha from horizontal. After time t, the direction of velocity makes angle beta with the horizontal. The velocity of ball at highest point of its path is. So we are given that ball is projected, assume with initial velocity u at an angle alpha, and after time t, arbitrary time t, the velocity is making angle beta the horizontal. So initially the initial velocity is u cos alpha I cap plus u sin alpha j cap, and at time t it is u cos alpha will remain same because there is no force in the x direction. Y direction it will become minus, and it is given that this velocity is making an angle of beta with the horizontal. So what this means is that this is the y component at time t and this is the x component at time t. This is making beta. So we can move this here. So we get that tan beta is ut by utx, which is u sin alpha minus gt divided by u, sorry, this was u cos alpha. So taking u cos alpha on that side, we get tan beta multiplied by u cos alpha is equal to u sin alpha minus gt, and we need to find u. So u will be equal to, first let us combine the terms containing u. Is tan beta alpha minus equal to minus gt. So u will be gt by sin alpha minus cos alpha, and we are asked the velocity of the ball at the highest point. That will be u cos alpha, that is gt sin alpha minus tan beta cos alpha multiplied by cos alpha. So now we can write this tan beta as sin beta by cos beta, which will give us cos of beta, and if we take this below, we will get gt by tan alpha minus of tan beta. That will be option C. Question 52 says a acceleration time graph of a particle moving in straight line is given starting from rest. The velocity time plot is best represented by. Since the particle is starting from rest, option A is obviously wrong, and option till this time t naught, the acceleration is positive and it is continuously increasing. But in option D, assume this is the slope here and this is the assume this angle to be 70 and this angle is obviously less than 70. Let's assume it. So tan 50 is less than tan 70. You know that. So the slope has decreased, and the slope is also the acceleration. Slope of VT graph is acceleration. But we know that acceleration is increasing, so it cannot decrease. So this option is wrong. Now in both option B, assume this is T, this T naught. So this slope is increasing till T naught. So both option B and C are correct till now, till T naught. But after T naught, this acceleration is still positive, but it is decreasing. So the velocity should still increase, but at a lower rate. But here we can see that the velocity is decreasing, which is not possible as acceleration is still positive above the x-axis. Now, also we can see that this is the slope. This is the slope. This angle is in the second quadrant. This angle is also in the second quadrant, which means that the acceleration is negative if we take the tan, because tan is negative in second quadrant. But here acceleration is positive. Option B is also wrong. Answer is option C.